Okay, let me practice my oral English. This paper, A Learned Representation for Artistic Style, is published in iClear 2017. The authors are from Google Brain. About the task, style transfer, we can see given the content image and a target style, we want to generate or transfer the image to with the given style. And for machine learning or deep learning, or we are also interested in the embedding or the representation of the style. Learn from the, we hope we can learn the embedding from the style or anything. So the common setting of style transfer is this one. Given the two images, style and content, we want to generate a pass-stitch image. The oldest method, I think maybe it's just transfer every single image. So it's very slow. Then improved one is that we can train a neural network or use the name generator to learn the style, to learn from the style and also the data. Then transfer after training, we can transfer any images. The pipeline, they use the network. They need to train the network with this loss. So we can see given the content image into the network, it will output. We call this one pass-stitch, right? So they have two components in the loss. One is measure the content, want to keep the content. So we can see they use how to measure the measure the difference between content image and the generated image. They use this VGG network. They get this is this image and this is the content image as input, and they get the output from several layers after the activation. They get the output feature map and measure the difference. So this is to keep the content. And for style loss, similar. They just want to match and show the match of the style. Most parts are similar. Here they have extra one is the G is the grand matrix. But some other papers or new papers did not use this one. So this one maybe is not useful in future works. Okay, so the drawbacks, we can see given a style, given for every style, they need to train a style network for it. So if we have n styles, it need to train n networks. So straightforward, a straightforward question is that can we train n styles in one network to reduce n to one, right? Or in other words, can we train a conditional transfer network? So how to use it? Since the network mainly use CNN, right? Use CNN, and the most components is the convolution network, like the convolutional layer, pooling layer. They basically they can do their thing. It cannot be conditional. It's not conditional, right? So they here for one style is one image. Then they found uh, previous work. Previous work you propose the instance normalization. So they propose a conditional one. Since one image can be treated as one instance, or the name it can be treated as one instance. So for one style, we can do the normalization. If we have n style, we can have n normalization for each one. And then for normalization layer, we can see given the input we can compute its own mu and sigma, and then they have this gamma and beta represent the scale and the bias. Then so the people the authors think every style has its own scale and bias parameters. So if we have n styles, we need n gamma and n betas, n gammas and n betas. Then we given a specific style, we select the corresponding gamma and beta to for training and also for uh, generate uh, generation or style transfer. So they extend the single instance normalization to with the code book. It contains n gamma and betas code book. Yeah, contains n gammas and n betas. So then they show they can use a single network, style transfer network to to for n styles. Okay, they can also use it for mixing. Uh, yeah, I think the mixing is because for like this one it has its own gamma and beta, and this one is have its own gamma and beta. So they can combine this one using mixing or linear interpolation. Then they transfer the content image and it show the results. We can see the performance. Some makes sense, but since it's not easy to measure it. Okay, summary. Uh, yeah, based on the baseline, depend since the baseline use need to train a network now, so it's very straightforward to it's very so we need to reduce n to one. How can we train n styles in one network? Then they uh, use the instance normalization, but conditional for but propose the conditional one. So for every single style, it has its own gamma and beta, the scale and bias for the instance normalization. Then n style, namely n instance normalization, will have n gammas and n betas. The number of parameters are n times c. One gamma have c, one beta also have c parameters. Okay, so then in training and testing, we will select the specific gamma and beta during training and inference. Okay, so the idea is very simple and it also very straightforward. The improve, improvement is clear. Reduce the 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 networks, the number of networks. Okay.